name is Ashish. I teach physics and mathematics on the platform The Excited States. I teach physics for various exams like AP Physics or SET and also for various entrance exams like IIT JEE and JEE Mains. In this video, I am going to explain you a problem on classical mechanics. Okay. So this is the question given that a ball is projected from the ground at an angle of 45 degrees with the horizontal surface. Okay, so this is the projectile and this is the angle 45 degree with the horizontal axis. Okay, it reaches the maximum height of 120 meter. It reaches the maximum height of 120 meter and return to the ground. Here it again return to the ground, strikes the ground and bounce again. Okay, after bouncing, after the first bounce, it loses half of its kinetic energy. Upon hitting the ground for the first time, it loses half of its kinetic energy. Immediately after the bounce, the velocity makes an angle of 30 degree with the horizontal axis. After the first bounce, the ball makes an angle of 30 degree with the horizontal axis. Okay, and the maximum height after the first bounce, it is h1. We need to find this h1. Okay, find the maximum height it reaches after the bounce in meter. So we need to find this h1. Okay. So this is the ground. This is our reference. So from our convenience, let's take sign convention. I am taking upward as a positive sign, downward as a negative sign. And we know that from the Newton's equation of motion, this is the third equation of motion, that is v square equal to u square plus 2a vector dot s vector. Here s vector is the displacement vector, a vector is the acceleration vector, which is constant. Okay, v square is the final speed square, u square is the initial speed square. Okay, so I am going to apply this equation before bounce. Okay, so before bounce, we know that maximum height is 120 meter. A is minus g because I am taking downward as negative sign, upward as a positive sign, and acceleration due to the gravity of the earth is in the downward direction from the perspective of an observer standing on the ground. Okay. Initial component of velocity in vertical direction is v naught sine 45 degree. Initial component of and final component of velocity in vertical direction will be 0 because when the ball reaches its maximum height, final component of velocity in vertical direction will be 0. Okay, so now apply this third equation of motion, that is v square, that is this v square equal to u square plus 2a vector dot s vector. Okay, b square, that is final component of velocity in vertical direction, which is 0. So 0 square equal to initial component of velocity in vertical direction, that is uy, is v sine 45 degree. Okay, before a ball strike first time to the ground. Okay, minus 2g into h. Why this minus? Because acceleration vector and displacement vector in vertical direction both will be in opposite direction. Acceleration vector is in the downward direction and displacement vector 120 meter is in the upward direction from the perspective of an observer standing on the ground. So g will be in downward direction, that is acceleration will be in downward direction, and displacement 120 meter, that is the maximum height, in upward direction. That's why this minus sign will come. Now on solving this equation, we will get sine 45 is 1 upon root 2. So v naught sine 45 square is v naught square by 2. So this is v naught square by 2. Okay, and this will come this side. So we will solve and we will get v naught square is 480g. Okay, so let's suppose this is equation 2. Now just after ball strikes the ground. Let's suppose its speed is v1. Let's suppose its speed is v1. Okay, and it makes an angle of 30 degree after the first strike, first time it hitting the ground. So initial component of velocity in vertical direction is v1 sine 30 degree, and we need to find this h1. And when ball reaches its maximum height, final component of velocity in vertical direction will be 0 and a will be minus g, as I have explained to you. So just apply all these data in equation 3. So we will get final component of velocity in vertical direction 0 is v1 sine 30 square, that is u square. This is initial component of speed, that is v1 sine 30 square in vertical direction, minus 2g h1. This maximum height is h1 in this time. This maximum height is h1. Okay, so when we will solve this, we will get h1 is v1 square upon 8g. h1 is v1 square upon 8g. So let's suppose this is equation 3. Now the condition is given that ball loses half of its kinetic energy when first time it strikes the ground. Okay, so what is the kinetic energy of the ball? Okay, so kinetic energy of the ball is half mv square, and after strike, after hitting the ground, its speed is v1, so its kinetic energy is half mv1 square. Okay, it will be half of, since half of its kinetic energy will be lost, now it remaining kinetic energy will be half of the initial. So initial kinetic energy that ball had is half m v naught square. Okay, so half m v1 square, this is the kinetic energy just after hitting the ground, and this is the initial kinetic energy that ball had. So from this condition we will get v1 square is v naught square upon 2. Okay, v1 square is v naught square upon 2. Let's suppose this is equation 4. Now combining equation 3 and 4, we will get h1 is v1 square upon 8g and v1 is v naught square upon 2. So just put the value of v1 square in this. We will get h1 is v naught square upon 16g. Just put v1 square in this equation 3. So we will get v naught square upon 16g. Now from the equation 2, let me show you equation 2. From equation 2, v naught square is 480g. And from equation 3 and 4, we got h1 is v naught square upon 16g. Now put v naught square from the equation 2, that is v naught square is 480g. V naught square is 480g. So h1 is v naught square upon 16g. 480g upon 16g, that is 30 meters. Okay, so the maximum height that ball will reach after the first time it strikes the ground is 30 meters. So our answer will be 30 meters. Okay, so this is the final answer. Thank you.